Hi students, to my sorrow, this is my last online lecture. So in the next week, I'll post a video lecture and you just submit a homework as an improvement of GUI. Okay, so there will be no online lecture on next Wednesday, but instead the homework will be posted, okay, on your desktop. A wonderful thing is that today's topic is very easy to understand. Even though the concept is somewhat hard to understand, but programming is really easy. So I expect all of you get 100 points today. So let me just start by switching to the lecture notes today. So today's topic is exception handling. As you know that you are expecting that there is some unusual situation, then you have to handle. In some cases, it is recoverable, then you'd like to recover from the erroneous condition. But it is not possible, then it is okay to terminate your code in a graceful manner, okay? But when you are going to handle some kind of exception, then you need some kind of situation which are capturing some erroneous condition inside of the exception object. So an exception object can also have several arguments which can be used for exception handling. To capture the problematic data, a user-defined exception is required since the built-in exception only receives the error message. For example, the following code captures a data item to specify actual cause of the exception. So as a review, I'll just explain the situation why the exception is needed. So once you are going to take a summation of numbers, so you may have these numbers such as 10, 21, 31, 45, then you can just print sum of excess. Okay, so you may save this and running this again. So it will print 107, okay? But sometimes you may have unexpected result as this one. How about, so in the middle of the integer data, there is a numeric data here. Okay, so you can execute this, but there is an error. Okay, so you'd like to make a more robust version of the summation. So instead of sum, you'd like to make a robust sum. So in order to do that, you have to define robust sum, which is accepting excess, and it will return total. Okay, and total may be initialized as 0 from the beginning. And you know that as a user, you can define this should be executed when the name is main. Okay. Once you save this, it is running like this. So as you know, the total is always 0, so that it doesn't anything inside of excess. Okay. But we can repeat on the data items using for every x in excess. You'd like to make a total, which is the result of x. But you would like to handle this kind of cases. Okay, so that is much similar to that. So, okay, let's just make an int of something. So if it is convertible to an integer, it would like to get an integer from it. Okay, so this is a more robust version. So you can execute this and 107, okay, as expected. Okay. But as you know, this is the so this is the case of the section 104. You may wonder that how about 2? Okay, and then 104 is a good number. Okay, since you are in the section 104. Okay, so it is so far so good, but sometimes it is more problematic, such as that you want to some of this, but 31 is entered instead of numeric 31. So how can I handle this? So it is much like a situation that if I ask Seokhyun, and Seokhyun is just, can you do me a favor? I'm asking you that, so please bring me a cup of Coke from the supermarket, okay? And Seokhyun is go to the supermarket and ask him, hey, can I buy some bottle of Coke? Then the clerk or the employee in the supermarket is saying that can say that we don't have any Coke right now. We only have Pepsi. Okay, so how can do something? You don't know because I asked him. Okay, so if you think, oh, Pepsi is okay for me, then you can buy it. But you don't know, I still want Pepsi or some other brand, okay? So in that case, the best solution is that calling to me. Hey, professor, there's no Coke in this market, then I can make you, oh, that's okay, then you can come back. Or I can ask him that in that case, please buy me some Pepsi instead. Okay, so the problem is that someone gets some unexpected condition. So unexpected condition may arise in different point than the handling point. So they are decoupled. That is the problem. Okay. In that case, someone is detecting some unexpected condition should raise an exception, just like calling to me. Okay, so you may try this. You may try this conversion to integer, but if it is not okay, then you may raise an exception. Except raise an exception, then it can be value error. Then you may raise it safely, value error. Okay. Then in this case, you may try that robust sum, but it is raising some value error. It is too slow. Value error, then I can print it. Oh, this is the error. Ignoring malformed data. So malformed data. Okay, so I'd like to inform the user there's a malformed data. Okay, so you can execute this. Malformed data is executed. So in that case, you don't need this try inside of robust sum because this value error will be executed in default. So just try except is okay. So the value error will be raised in default. Okay, so it is same as before. Okay. But in some cases, the user want to know what is the malformed data. Okay, you know that in this case, 31 is a malformed data. Okay, so he want or she want which is the malformed data. So the user may want to locate which one is actually problematic. So in that case, you have to convey the data item in your throw raising an exception, when you are raising an exception. So in that case, please define a user-defined error. So that is required to capture. So data error may be extension of an exception, and you may pass it. Okay, so you may try it. So I'd like to make it here. Try it. And if something is value error is occurred, then you'd like to raise data error instead. Okay, so you are just converting the exception in your term. Okay, in that case, this is not handled properly. Okay, so data error raised, but there's an ugly message because it is not handled. Okay, so you want to handle data error instead. Then it is converted safely, and you'd like to just print malformed data. But still, I don't know which one is the problematic data. So in order to do that, you have to make an initializer as a constructor. So let's make it def done the init. And the first parameter is always self, and second is the problematic data, and the third one is a message whose default value is error malformed data. Okay, then you'd like to call the super constructor of the superclass. So self dot message is invoked as a superclass init, and then you'd like to set self.data as a malformed data here. So your data error object is currently storing the data. So in order to do that, you have to make a data error with an argument, which is the problematic data. In this case, X. Okay, so you have to, it is safely converted to a data error, and the data item is conveyed to data error exception. Okay, then you can print it inside of malformed data. So let's convert this as a format string, and you can print the inside of your format string. So let's just convert this as a double quote. So inside of a format string, so you need to access the exception. So SE is an exception. So you'd like to E.data. Okay, you'd like to extract E.data. So let's quote this as a single quote inside of the double quote. Okay, so saving this and running this again. Malformed data 31. So this is the way how the problematic data is captured inside of your exception. Okay. Further, you can make it more encapsulated version by defining that cause. What is the cause? Okay. Then you can return self.data. Since the self.data is a data field inside of a data error, it is not a good way to use it directly. Instead, it is okay to make it as a method, and calling method is more good than directly accessing the data field. So in this case, E.cause. So what is the cause? It is a 31. Okay. So this is more good because It is more encapsulated version. Okay. So let's go back to today's problem. So I just explained this, but it is still using unencapsulated version e.data. Okay, but you can make a more encapsulated version. So I'd like to make it shorter as an example. So if it has no problematic, so it is okay. So I can show you in this robust sum. So in your main file, you may have YS is a good version, 10, 21, 31, 42. And ZS may be another problematic version, but 21 is maybe problematic, 31 may be problematic, but it is okay to, not GA, GS. It is okay to, it is recoverable from the robust sum. So you may want to LS in XS, YS, DS. Okay, so you'd like to try the robust sum again. Okay, so if there is an error, it is neglected by the malformed data. So in your first case of XS, so it will be covered malformed data, but in other case, it will be printed as a robust sum. Okay, so let me execute this again. 31, 31. Why? Because I was not using LS here, so let's use LS instead. Okay, so I just repeating 3 times for XS. So malformed data for 31, but 104 is good for the YS and ZS. So in order to make it more safely, so you'd like to print summation of sum of LS, okay, equal to, then you'd like to make it end with empty line, okay? Then you can make this more readable. You'd like to try some this one, malformed data. Some of this one, 104. Some of this one, 104, okay? So let's go back. Any questions up to here? The questions. So let's go back to your lecture note. Today you want to execute RDIV, which is robust division. Okay, so write a robust version of division program that repeats an integral division on a given number until the quotient becomes 0. If any of the dividers is 0, your program should raise a user-defined exception and handle it. To handle an exception, the number of divisions performed up to that point should be printed enclosed by a pair of parentheses. Your program should repeat this procedure until the quotient becomes 0. Okay, so once you divide it, the remainder should be divided in sequence. So input consists of 2 lines. The first line contains a dividend, a positive integer, and the second line contains the sequence of positive integral dividers separated by space. But there can be 0 as a divider. Your program should print the quotient per line until it becomes 0. If a malformed divider is given, which is 0, your program should terminate. No, a malformed, which means that other than 0, your program should terminate. So let's take a look of the example. You know that 1021, and there's a dividers here. So once you divide it by 500, and the quotient is 2, and the remainder is 21, okay? And the remainder should be divided again by 6, okay? And 6 times 3 makes 18, so the quotient is still 3. And the remainder is 3 again. So you'd like to divide it by 0, but it is not possible to divide it by 0. In that case, you should print the number of divisions up to that time. So 2 divisions has been performed up to that time. Then the number of divisions should be printed enclosed in parentheses. Okay, so this is the quotient. This is the second quotient. This is an error case, but number of divisions before that. But you can still have 3. So divide it by 3 will make quotient 1, and the remainder is 0. So 1 is printed. Okay, but 0 divided by 2, then quotient is really 0. Okay, so you should terminate. Okay. So how about 1,910? Okay, so you'd like to divide it 829. In that case, the quotient is 2. Okay, and the remainder, maybe I can calculate in another window. You don't have to, you can check it by yourself. Divide by 829. 829 is 2, but the remainder is that 829 is 252. Okay, so you'd like to divide it by 1, but 1 is not a good form. Okay, so it is a malformed data. So you should terminate at that point. Okay. So there's 2 kinds of exceptions. One exception is that divide by 0. In that case, you should print the number of divisions up to that point. Okay. In the second case, there is a malformed data. In that case, you should terminate. Okay. So additional requirement, you have to define and use a designate function computing the division. So please make it a separate function for the division. You have to define and use an additional user-defined exception to handle the malformed dividers, such as the second case, 1. Okay. And third one, complete the survey on the style checker in the following link. You can click the link, and there will be shown another survey, a short survey. But you can still do this even though it is not, you didn't complete the current program, okay? After the closing today's material, okay? It is open until midnight, okay? So do you have any questions on the problem? Any questions?
그 문제 아까 그 1021에서 500 나누고 두 번째 출력값은 어떻게 나오는지 다시 설명해 주실 수 있나요? 아까부터. 네.
Okay. So I'd like to make this as an idle screen. Okay, so let me show you. So you know that 1021 divided by 500 is 2. So 2 is printed. Okay, but 21 modulo by 500 is 21. Okay, so you have still 21 objects to be shared. Okay, and 21 divided by 6 will make 3. So 3 is printed. Okay, so 21 modulo 6, so 3 is remain. but you'd like to try 3 divided by 0. This is an error. Okay, so you have to print the number of divisions before that. So the number of divisions is 1, 2. So you should print 2 instead. Okay, and after that, you'd like to divide it by 3. It will make 1. So 1 is printed. Okay, but you know that there's no remainder. So once you try to divide it by 2, it will make a 0. Okay, so it is not printed since the quotient is 0. So any other questions?
교수님. 교수님.
Okay.
괄호 안에 들어가는 숫자 기준이 뭔지 알 수 있을까요?
Number of divisions performed, which was performed before, which was successfully performed before the 0 division. Okay, so you know that there's 2 is performed as a division result, 3 is performed as division result. So you know that the 2 successful divisions performed before the malformed division. Okay, so 2 should be printed. So let me take another example. If you have, what is a good example? I don't know. 900. Okay, so let me just share this again. Initially, you have 31, and you'd like to divide it by 900, and 1 should be printed. Okay, and the remainder is 121. Okay, and you'd like to divide it in 50. 121 divided by 50. So let me assume the second number is 50. Okay, then the result is 21 by 121. The modulo by 50 is still 21. Okay, and third number may be 6, 121, or 7. Okay, 7, then 17 should be printed. Okay, sorry, 21 divided by 7, 3 should be printed. Okay, and the remainder of it is 0. Okay, then you'd like to try 0 divided by 0. Okay, this is an error. Okay, so you should print the number of divisions before that. The first one is, so you should count 1. Second one is, you should count 2. And third one is this. So you should count 3. So you should print 3 because number of 3 divisions were successfully performed. So what is the second question? Malformed divider 31? Yes. Is it okay? No? 31 is a string. Yes, so the string 31 is a malformed divider. But if you was if your input maybe (829, 31, 2), and the second one, okay, this one is malformed divider. Okay, is this clear, Yunji? Okay, so Song is asking me that what is the number in the parentheses. So your program should raise a user-defined exception. Here, the number of divisions performed up to that point should be printed in close the pair of parentheses. Okay, this is the answer. And I explained it here with another example. Okay? Any other questions? The questions? Okay, then you have about 50 minutes to go. If you don't have any question, then this is the end of today's lecture. So let's call it a day and see you on the final exam. Bye bye. 수고하셨습니다.